Hello everybody, a very good evening to all of you. Welcome to the live session by Infinity learned by Sri Chaitanya. I am Misbah, your maths educator, and in this session we are going to revise rational numbers and their decimal representations as well as irrational numbers, and then we'll be seeing how to prove irrationality of irrational numbers. So let us start with it. So the first thing is we have to revise the definition of rational numbers. So a number which can be written in the form of p by q, where p and q are integers, is not equal to 0. So any number of this form, for example 8 by 9, that is a rational number, ratio of two integers where denominator is not equal to 0. It can be obviously negative as well, minus 7 by 3, this is an irrational number, ratio of two integers where denominator is not equal to 0 is an irrational number. Basically, rational is coming from the word ratio only. Right, and the collection of all rational numbers, it is represented by the letter Q. It comes from quotient. The collection of all rational numbers, it comes from the word quotient. Quotient means the result of division. Divide something by some other thing, the result is known as the quotient, right? Hi Shining Star, welcome to this session. Hello Shubham. I hope that is clear over here. So 0 is also a rational number because 0 can be written as a ratio of two integers where denominator is itself not equal to 0. So in fact, any integer is a rational number as well. For example, minus 8, because it can be written like this. For example, minus 12. So every integer, for example 100, every integer is a rational number because it can be written as a ratio of two integers where denominator is not equal to 0. Now what about the decimal representation of rational numbers? So decimal representation of rational numbers can be of two types. It can be a terminating decimal representation. For example, 1.73. This is a rational number because it's having a terminating decimal representation. Terminating means it is stopping after some place of decimal. It is stopping after it. Therefore, the word terminating, to terminate means to stop. So the decimal representation of a rational number can be terminating. For example, 0.238. This is a rational number because it is having a terminating decimal representation. Or it can be non-terminating repeating or recurring decimal representation. So non-terminating repeating will be something like this. For example, you see, so it is not terminating, it is not stopping after any place of decimal, but you see it is repeating. So the part of the decimal which is repeating, we put a bar over it. The part of the decimal which is repeating, we put a bar over it, and this bar is called as vinculum. This bar is called as vinculum. So this is just a revision. The detail of this was there in grade 9. So I'm not discussing about the details of it. Like for example, the p by q representation of a non-terminating recurring decimal representation, that is also there in grade 9. Right now I'm just revising that two types of decimal representation of a rational number can be there. It can be either terminating or non-terminating but recurring or repeating decimal representation. So the word recurring means reoccurring. It means it is happening again and again. So it is coming from the word reoccurring. I hope that is clear. No, actually, are you talking about the numerator as well as the denominator, I guess? Yes, Shubham. They can or cannot be co-prime, no problem in that. For example, if you have got 8 by 16, this is also a rational number. The definition of a rational number is ratio of two integers when denominator is not equal to 0. So they may or may not be co-prime, no problem in that, if you talk about the definition of rational numbers. So, but whenever you will get any two numbers, every time you can simplify it such that the numerator and denominator will be co-prime. You got that or not, Shubham? Even if they are not co-prime, it can be simplified such that the numerator as well as the denominator will become co-prime. But if you talk about the definition of rational numbers, then it is not compulsory to write the word co-prime there. But every time you will be able to do that in the form of co-prime. I hope that is clear. We'll do that. We haven't started doing that, Shubham. Now, what about irrational numbers? A number I'll give an example. For example, you see this thing. So this is an irrational number. It is neither terminating. When you use these three dots, so it is not terminating. It is not stopping after any place of decimal. And it is not repeating as well. Neither terminating nor repeating. Then that type of number is called an irrational number. A number having neither terminating nor repeating decimal representation is called an irrational number. For example, root 2 is an irrational number. Its decimal representation will be neither terminating nor repeating. Root 3 is an irrational number. Its decimal representation will be neither terminating nor repeating. In fact, square root of any non-perfect square number will be an irrational number every time. You see, 18 is not a perfect square number, so root 18 will be an irrational number, right? In the same manner, but if you will take root 9, that is a rational number because 9 is a perfect square number. So square root of a non-perfect square number is an irrational number. 10 is a non-perfect square number, so therefore its square root is an irrational number. I hope that one is clear to everybody. Right? In the same manner, you can understand about cube root as well. For example, cube root of 10 is an irrational number. Why? Because 10 is not a perfect cube number. In the same manner, if you will take 27 cube root of it, this is not an irrational number because 27 is a perfect cube number. You got that? 27 is a perfect cube number. So in the same manner, you can take fourth power as well. For example, fourth root of 16 is 2. So that is not an irrational number. But if you will take fourth root of 18, that is an irrational number. Because 18 cannot be written as the fourth power of an integer. Is that clear? I hope that is clear to everybody. Now you might think, you might ask that why root 2 is irrational. That we will prove. But there is one more simple way to understand. You have studied long division method to find square root in grade 8, yes or no? Long division method to find square root up till grade 8. So when you will find the square root of root 2 using the long division method or root 3 using the long division method, you will see that it will have a non-terminating, non-repeating or non-recurring decimal representation. That is one way to understand it. It will have non-terminating nor non-repeating decimal representation when you will find the square root of root 2 using long division method. I hope that one is clear. Now one more category is, for example, pi. Pi is an irrational number. Pi is not equal to 22 upon 7. 22 upon 7 is just an approximate value of pi for calculation purposes. You can never ever find the exact value of any irrational number. You can just find their approximate values. Pi is never equal to 3.14. Those are just approximate values. Pi is never equal to 3.143 and so on. These are just approximate values of pi for calculation purposes. So basically you have got this pi and then there is something called E, Euler's number. So these are different category of irrational numbers called transcendental numbers. Let's not go into detail of that because that is not the purpose of this session. Transcendental numbers. Transcendental numbers. Okay, pi, irrational, you have got Euler's number, there is something called golden ratio and all that. These are different category of irrational numbers called transcendental numbers. I hope that is clear up till here. So these were basics of what is a rational number and what is an irrational number, and we have talked about the decimal representation of them. Is it clear up till here? Just confirm that. Shubham, Srishti. The basics of irrational numbers and their decimal representation. Now here comes the part for which this session is actually. This session is for how to prove irrational numbers, and that too as per your syllabus. When it comes in your board examinations, how will you prove it, right? So before that, if you want proper career guidance or which stream to choose after grade 10 and how to prepare for board examinations or competitive examinations, you can request a call back from our expert academic counselor, for which you have to fill the Google form which is given in the link of which is given in the description below. So you can do that after this session. If you want proper career guidance, which stream to choose, how to prepare for boards or competitive examinations, you can request a call back from our expert academic counselor, for which you have to fill the Google form, the link of which is given in the description below. Or are you preparing for JEE 2025? For that as well, you can request a call back from our expert for any help, for which you have to fill the Google form, the link of which is given in the description of this session. That can be done. The same goes for NEET as well. If you're preparing for NEET 2024 or 2025, you can request a call back from our expert academic counselor at Infinity Learn by Sri Chaitanya, for which you have to fill the Google form, the link of which is given in the description of this session. So you can do that as well after this session, right? Okay. Now, the main purpose of this session is to prove how to prove root 2 an irrational number, root 3 an irrational number, or questions like that. So for that thing, you have to understand one theorem. Let P be a prime number. If P divides A square, then P divides A as well. Understand this thing properly. For example, 5 divides 25 square, right? 5 divides 25 square. Divides means 5 is a factor of 25 square. You got my point? Then obviously 5 is a factor of 25 as well or not? Or 5 divides 25 as well or not? Every time it will happen. But it will every time happen when this is a prime number. When this is a prime number. For example, see one thing. For example, 4 divides, maybe I will write like this. 4 divides 6 square, right? 4 divides 6 square or not? 4 is a factor of 6 square. 6 square is 36. 4 nines are 36. But do 4 divide 6 as well? Tell me. No. 4 is not a factor of 6. You got that point? So basically this is not happening because 4 is a composite number. It is not a prime number. 4 is not a composite, 4 is a composite number. This rule will happen when this number is a prime number. Over here 4 is not a prime number. So therefore this rule is not happening. This is not standing true. Is it clear? But if it is a prime number, every time it will be 100% true. Every time it's going to be true. That if P is a prime number and if P divides A square, or you can say P is a factor of A square, then P will divide A as well. Or you can say P is a factor of A as well. Is that clear, Shubham, Srishti? So this can be done. Actually, there is a proof for it as well, but that proof is not asked in the examination, so we are ignoring that thing, right? The main purpose of this session is to understand this property, and then we have to understand how to prove irrationality of root 2, root 3, root 5 like these numbers. Any doubt in this session? Just confirm that once so that we can move on to it. Okay. Now there is one thing called contradiction. Contradiction. Actually, we will be doing proof by contradiction. Contradiction means when you have, things which are clashing with each other. They are contradicting with each other. It means you have assumed something to be like X, suppose, but while moving through the process, you are getting something Y. It means what you have assumed in the earlier steps, you are getting something opposite of that. So that is contradiction, contradictory statement, you would say. You got my point? So basically you have to learn this method. I'm being honest in that case. You have to basically learn this method, and this will be asked in the examination. At least one question will be 100% sure asked in the board examination. On the basis of proof of irrationality. So let us do this thing. So for example, prove root 5 is irrational. So anything can be asked in the examination. It can be asked root 5 is irrational. Somebody can ask root 2, root 3, anything like this. Root 8 also can be asked, no problem in that. So these things can be asked in the examination to prove them to be irrational. Is it clear? Prove them to be irrational. For root 8, it will be a bit different, okay? This is basically for prime numbers inside the square root. It can be asked in the examination. That is not in the syllabus, therefore I am not taking that, Shubham. Otherwise, obviously, we can very well do that, okay? Please understand this method first. So root 5 is irrational, so we have to do proof by contradiction. So the first thing is, let root 5 to be rational. Let root 5 to be rational. Right? Yes or no? If it is rational, what can we do? Therefore, can we not say that root 5 is equal to p by q, where p and q are co-prime integers? That is the definition of rational numbers. Are co-primes, that I have already explained, Shubham, that they will be co-primes. Even if you don't take p and q to be co-primes, at the last step, they will come out to be co-primes, because there might be other methods as well, but we are working as per the syllabus. This is basically board syllabus. So whenever something is asked in the board examination, you have to move as per NCERT, especially in proofs. Yes or no? One more logic I had proved already, Shubham. One logic was when you will do the actual division. I had explained, please concentrate on the board. When you will do the long division method, when you will find the square root of root 2 using the long division method, which you have studied in grade 8, you will automatically get a non-terminating and non-repeating decimal representation. So that is one way of showing that root 2 is irrational. You got my point or not, Shubham? So p and q are co-prime integers. And q is not equal to 0. Correct? And q is not equal to 0. Now, can we square on both these sides over here? Root 5 square, that is equal to p square upon q square or not? So from here, can we say 5 is equal to p square upon q square? Right? Now from here, if I take q square over here and p square over here, what will I get? Will I get q square is equal to p square upon 5? So what does it mean? See it very patiently. That is the definition of irrational numbers, Shubham, which I had already explained in this class itself. The definition of rational numbers, even if you don't consider them to be co-primes, they will be co-primes, right? I had taken the example of 8 upon 16. Even if you don't consider to be co-primes, after simplification, they will come out to be co-primes only. Is that clear? Okay. Now you see, this is an integer, because p and q were integers. An integer divided by 5, q is also an integer. So p square integer divided by 5 is also an integer. So what does it mean? Does it not mean over here that therefore we can say that 5 divides p square? Yes or no? 5 divides p square, or 5 is a factor of p square. Is that correct? Because you see now, an integer divided by 5 is coming out to be an integer. So that means that 5 is a factor of p square. So therefore you can say 5 divides p as well. We have studied the property in the previous slide, because 5 is a prime number. If 5 divides p square, 5 will divide p as well. So if 5 is dividing p, what does it mean? If 5 is dividing p, it means p divided by 5 will also be an integer. Yes or no? P divided by 5 will also be an integer or not? So from here, can we not say that p is equal to 5x? Correct or not? We can say p is equal to 5x. And suppose this is the first equation. So can I put p is equal to 5x in the first equation, guys? See this. P is equal to 5x we can put. So q square is equal to 5x the whole square upon 5. So if you simplify, you will get q square is equal to 25x square upon 5. 5 ones are 5, 5 5s are 25. So from here, can we write over here that q square upon 5, that is equal to x square? So what does it mean? It means that this is an integer divided by 5 is another integer. So we can say over here that 5 divides q square as well. 5 divides q square, or 5 is a factor of q square. So 5 divides q as well. We have studied this property. Because 5 is a prime number, it is dividing q square, or it is a factor of q square. So 5 will divide q as well, or 5 is a factor of q as well. Now, isn't this a contradiction? You see, we have assumed that p and q are co-prime numbers. P and q are co-prime numbers. Yes or no? But what we are getting? Over here, we are getting that 5 divides p and 5 divides q. It means, therefore, 5 is a common factor of p and q. Factor of p and q. Isn't this a contradiction? Because p and q were co-prime numbers, so they must not have any common factor except 1. But we are getting over here that they are having a common factor except 1. This is a contradiction. This is a contradiction. And then you have to write in your answer that this contradiction arised due to our wrong assumption of taking root 5 to be rational. Hence, root 5 is irrational. You have to write this in your answer. This contradiction arised due to our wrong assumption of taking root 5 to be rational. Hence, it is irrational. Because if it is not rational, then the only possibility is that it is irrational. Is it clear? Hi, Jasmeet. We are not taking doubts over here, Ayushman. This is not a doubt session. I hope you understand. I mean, apart from this question, I'm saying, apart from this concept. Is it clear up till here? Good evening, Jasmeet. You have to write after this that this contradiction arised due to our wrong assumption of taking root 5 to be rational. Hence, root 5 is not rational, it is irrational. I hope that is clear up till here. Any doubt in that thing, guys? Just confirm that. No, we will do that as well. I hope that one is clear. Now you see, the second category of question will be like this. I hope you are asking this only, Srishti. The second category of question, that how we have to prove this to be irrational. The very first thing which you have to understand is, whenever they will give this type of question, they will give it of maximum marks, most probably of 5 marks or 4 marks. Whatever is the maximum marking given to a question in the question paper, they will provide that to this type of question. Prove that root 5 is irrational, root 2 is irrational, root 7 is irrational, root 3 is irrational. But when they will give this type of question, they will give it of 2 marks or maximum 3 marks. The simple reason is, most of the times it will be given in the question that prove that root 7 plus 2 root 3 is irrational, given that root 3 is irrational. It means it will be given in the question that root 3 is irrational. If it is not given in the question, you don't have to separately prove root 3 to be irrational. That you have to assume, because the answer, the question will be of 2 or 3 marks. It will not be more than it. I hope that one is clear. But suppose it is coming of 5 marks, you have to prove separately root 3 to be rational, to be irrational. Now the same type of logic, we have to assume let 7 plus 2 root 3 to be rational. Again, proof by contradiction. We have to assume it to be rational over here, right? Now, therefore, if it's a rational number, therefore, 7 plus 2 root 3 is equal to p by q, where p and q are co-prime integers. It will come in the examination. You have to understand this type of question, co-prime integers, and q is not equal to 0, right? If it is separate, you have to use always Srishti. If it is having any combination of rational and irrational number, you have to do like this. Basically, what you have to do, you have to separate out the irrational number over here. You see this. This can be written like this, p by q minus 7. And then we can just further simplify 2 root 3, that is equal to p minus 7q upon q over here. So what about root 3 over here? Tell me, Srishti. Root 3 is equal to p minus 7q upon 2q. Is it clear? Now basically q are co-prime integers, right? P and q are co-prime integers. So therefore, isn't this this is also an integer or not? Tell me. This is also an integer. If p and q are integers, then p minus 7q will also be an integer. And this is also an integer or not? Tell me. This is a non-zero integer or not? Tell me. Because q was not 0. So can I not say that this thing is rational? Ratio of two integers where denominator is not equal to 0 is a rational number, right? Ratio of two integers where denominator is not equal to 0 is a rational number. And over here, this thing is irrational. This thing is irrational. This thing is irrational. So you see, an irrational number is equal to a rational number. This is a contradiction or not? You see, but you have to write these things. But rational is not equal to irrational. So at last you have to write the same type of things, right? Rational is not equal to irrational. Hence this is a contradiction. Hence this is a contradiction. And then you will write this contradiction arised due to a wrong assumption of taking 7 plus root 3 to be a rational number. So if it's not a rational number, there is no other possibility but to say that 7 plus 2 root 3 is irrational. Is it clear? These two sentences at last you have to write. This is a contradiction, and this contradiction arised due to a wrong assumption of taking 7 plus 2 root 3 to be rational. Hence it is irrational. I hope this is clear. So these two types of questions are there. They will change values every time and they will give you questions to you. One more last category of questions, question is there in this thing, proof of irrationality. The last category which can be asked, and after that nothing can be asked on the basis of proof of irrationality. The last category is this thing. Prove that root 7 plus root 11 is irrational, or sometimes they might give you a question like this, prove that square root of p plus square root of q is irrational when p and q are prime numbers. They will give you a question like this as well. It is the same thing, right? Because 7 and 11 over here, they are prime numbers. I hope that one is clear. So again the same thing. Again you have to assume it to be a rational number. Let root 7 plus root 11 to be rational. Let it to be rational only. The only possibility is this, right? Now over here, if it's a rational number, can we not say over here that root 7 plus root 11 is equal to p upon q, where p and q are co-prime integers? We can do like this over here. Same thing. Over here as well, similar thing is to be used. Basically, you have to separate out an irrational number on one side and then automatically you will get a rational number on the other side. But the method would be a bit different. Over here, basically, you have to square on both these sides. This type of thing. Squaring on both sides. So if you square on both these sides, what will you get, guys? So over here you can use a plus b the whole square identity. So that will give you root 7 the whole square plus root 11 the whole square plus 2 root 7 root 11, and that is equal to p square upon q square. Now you see over here, root 7 square is 7, root 11 square is 11, 7 plus 11 is 18. So after simplification, what will you get over here? That is 18 plus 2 root 77 will come, right? And that is equal to p square upon q square. I hope that one is clear, guys. Yes, that will be root 77. That's correct. Now you see over here, again we have to just take an irrational number on one side of the equation. So you see this is p square upon q square minus 18, and after further simplification you'll get p square minus 18q square upon q square. Now you see 2 you can take in division over here on the other side of the equation. So what will you get? That will give you square root of 77, that is equal to p square minus 18q square upon 2q square. Now you see p and q are integers over here. P and q are integers. It means this will be an integer as well. Yes or no? This will be an integer as well. And the denominator is a non-zero integer. So can we not say over here that on this side of the equation you have got a rational number? Ratio of two integers when denominator is not equal to 0 is a rational number, right or not? And on the other side of the equation you have got an irrational number. This is an irrational number. Now you see, this is a contradiction. An irrational number cannot be equal to a rational number. You got that logic? No, even if it is not given in the question, because 77 is not a perfect square number, you can write one sentence over here that root 77 is irrational because square root of a non-perfect square number is an irrational number. That one sentence would suffice. You don't have to separately prove root 77 to be irrational. You got that? That one sentence would be enough. That square root of a non-perfect square number is an irrational number. So you can say this is a contradiction because an irrational number can never be equal to a rational number, and this contradiction arised due to our wrong assumption of assuming root 7 plus root 11 to be rational. Hence root 7 plus root 11 is an irrational number. Is it clear to every student up till here? Just confirm that once, guys, in the chat. So no more type of question can come in the examination on the basis of proofs of irrationality. You must not have any single doubt in this thing because 110% sure it is going to come in your board examinations. Any one out of these questions, proofs of irrationality, will come, because in the first chapter, that is real numbers, as per the syllabus of CBSE, only two things are there. That is the fundamental theorem of arithmetic and proofs of irrationality. I mean, no more than this will come in the board examinations. I'm not talking about foundations and things after that, NTSE, IOQM and all that. I'm just talking about your board examinations. Everything is going as per the flow, Jasmeet. You will be seeing classes of the next week. They are also defined on the Infinity Learn Class 9 and 10 YouTube channel. Please don't forget to like, share and subscribe so that you'll keep yourself updated, right? Everything is going as per the syllabus. Now basically there is one feature on the Infinity Learn app that is called create your own test. So basically you can select the subject over there and select the chapter and select the question type like MCQ and all that, and you have to select the difficulty and select the time. So you can make a test as per your own wish, like you want to get yourself checked in what area, in what time, in what chapter, in what question type and all that. That can be done, and this is a unique feature on the Infinity Learn app. So you can please download the Infinity Learn app and you can do this thing over there. In short, we call it CYOT, create your own test, which can be done. Yes, I'll be taking that, Jasmeet, right? And also don't forget to subscribe to the Infinity Learn Class 9 and 10 YouTube channel, because then you'll be keeping yourself updated with the sessions over there? Yeah, that can be done, Srishti. That's what I'm saying over there, right? Then after that, you can subscribe to the Instagram handle as well and the Facebook thing. And don't forget to subscribe to the Telegram channel, because whatever is discussed in this session, the PDF of this session will be shared on the Telegram channel as well of the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to download the app, the link of which is given in the description below. So you will see the sessions of the next week. The complete next week is already defined on the Infinity Learn Class 9 and 10 YouTube channel, and it will be happening in the same manner in the future as well. So if there is any confusion or any doubt, you can also put in the comment section after the class. So that's all we needed to discuss in this session, guys. I'm Misbah, your maths educator. We'll meet in the next session. Bye-bye. Take care, everybody.